What's going on, everybody? Welcome back to Grand Theories, Episode 2. I am your host, Mark. This is a podcast that explores lesser-known ideas that try to explain really big things about the world we live in. And on today's episode, we will explore the attempt to merge two very disparate fields together: quantum mechanics and the social sciences. And the idea to me is something that's exciting because it tries to smash together the very big, our society, with the smallest things we know, which is subatomic particles. And really intuitively, the two just are very hard to connect. But as you'll see today, trying to merge them does make some sense. In fact, it might even make more sense than how we build our social sciences physically. And the implications of quantum social science, if it were to develop fully, could mean an upending of how we understand our society and our connections to one another. So today we'll learn how this idea came about, dive into the basics of quantum mechanics, hear how these principles can be fused with those of social science, and ultimately try to interpret the deeper meaning behind all of this. Today's story is a winding tale that spans the evolution of the mind of one scholar. And in order to get the full scope of this tale, we need to start with the field of international relations, which is the study of nations and how they interact with one another. International relations, or IR for short, in a broader sense, is a pretty young field. It really only picked up as a serious academic endeavor in the 20th century, but its oldest roots go much further back than that. There are a number of people who have attributed a 5th century BC ancient Greek historian named Thucydides as the spiritual founder of international relations. Thucydides wrote extensively about the Peloponnesian War, which was a conflict fought between Sparta and Athens. And in his writing, Thucydides dissected the Athenian motivations in attacking and conquering a very small, weak island named Melos. Melos was quasi-aligned with Sparta during the war, but they weren't involved in the combat in any way. Geographically, the island had very little strategic significance, but despite all of this, the Athenians chose to invade Melos during a truce with Sparta. The Melians refused to fight, but they also refused to join Athens in their alliance. At that point, the Athenian troops committed genocide, wiping out a large portion of the defenseless population and subjugating the rest of them. It's a sad and vicious story, but Thucydides did try and get underneath what motivated the Athenian actions. And in his writing, he suggested that the Athenians were making a strategic move, a move that had nothing really to do with the island itself. Instead, Thucydides suggests that the move is a display to Sparta that Athens is a brutal, powerful opponent and that they shouldn't be tested. It also simultaneously served as a message to other territories under the control of Athens, showing them what their fate might be if they ever thought about rebelling or seceding. This cynical way of thinking forms the bedrock for the first and longtime dominant school of thinking in IR, aptly named realism. Realists hold the view that the primary determinant of how countries view each other, interact with each other, and ultimately make strategic decisions is through calculations of power relations. Material qualities like a country's military strength, technology, GDP, geography, and so on and so forth, are the primary factors that nations take into account in determining how to handle one another. The school, while arguably cold and cynical, is logical, economical, and can predict quite a bit in a warlike world. After the end of the Second World War, we entered a period of peace and stability that's often referred to as the Long Peace. And it was during this time that a new view started trending in IR theory, something known interchangeably as liberalism or idealism. This school became popular as international organizations like the United Nations came to fruition. What liberal theorists hold is that nations are incentivized to cooperate with one another, and that the benefits of this cooperation outweigh those of taking military action. Considering that in 2019 it's now been over 70 years since the last World War, this view certainly does hold some weight. But the quote-unquote long peace has had plenty of regional conflicts and civil wars, and to this day there are still many realists who take issue with idealist thought. Now, there were other ways of thinking and theories that proliferated the field of IR. But between the, say, 60s and late 90s, IR was mostly a battle between various modifications of realism and idealism. It wasn't until 1999 that we meet the protagonist of today's episode, Alexander Wendt. Now, you may remember Alex from our first episode on grand theories, where I briefly mentioned that he had asked the question of whether or not nations can experience consciousness. This is a creative question for sure, and it's this creativity that drives today's central subject matter. In 1999, there was a new school of thought being applied to IR called social constructivism. Social constructivism is a broad idea that originated outside of international relations and had been applied across many disciplines, perhaps most famously in education. The main idea that underpins social constructivism is that the way we learn about our world and how to exist within it doesn't come from observing it or prior knowledge, but through the social interactions that we engage in. During the 90s, there were a number of theorists, Alex Wendt being one of them, who were attempting to apply the logic of social constructivism to the field of IR. The entire effort arguably peaked in late 1999 when Wendt released a book titled The Social Theory of International Politics. In the book, one argues the thesis that the main factor that determines how states interact with each other is neither power nor cooperation. Instead, it's the values that nations hold and the ideas that they share about one another. In Wendt's world, nations can view each other in one of three ways: as enemies, as rivals, or as friends. As such, states in their interactions will either emphasize power, cooperation, or some combination of the two, depending upon the stances that they take about each other. To exemplify, one suggests that in its diplomatic relations with North Korea, the United States will certainly take into account the small handful of nukes that the North Koreans possess. In contrast, even though the United Kingdom might possess 100 times more warheads, the U.S. certainly won't factor those in the same way that they do as with North Korea. Wendt's system gets more complicated as he dives into how exactly individual nations end up assigning these statuses to each other. He argues that the social activity that takes place between the world's 200-plus countries is what creates, maintains, and changes these perceptions. From here, one proposes that every single tiny micro-interaction that takes place between two or more countries causes small incremental changes in the overall bigger picture of what the world system looks like. Over time, these hundreds and thousands of interactions add up to really big changes. From here, the broader social structures then reflect back onto individual nations, causing nations to slowly tweak their old values into new, updated ones. This entire scenario is pretty complicated and leads us to a strange chicken and the egg problem, causing us to wonder what came first, the nation or the system of nations. In trying to picture Wendt's world, I can't help but think of the endless image that's created when two mirrors reflect upon each other. His world is never still, it's always constantly evolving. In Wendt's world, nation-states both socialize and are socialized by each other and the totality of who they are. As I had alluded to earlier, Wendt's work did become a monumental force in international relations, so much so that he's one of the field's most cited scholars during the 21st century. He approached the field with a scope and complexity that had really only been seen a handful of times before. His book got a lot of love and praise, but at the same time there was a lot of criticism, some of it even a bit vitriolic. Some of the dislike focused on Wendt's sacrifice of immediate empirical evidence for a grand framework that could explain everything. In this sense, I tend to characterize Wendt as unique in the field of international relations. He seems constantly distracted by what the deep future could hold. And this is in bleak contrast to IR's typical orientation in the past or the present. As an example of this, while some scholars argue whether or not a world government could or couldn't exist, Wendt believes that we will, without question, inevitably move to a world model sometime in the next couple hundred years. In one anthology, which is mostly composed of a series of 9 criticisms of Wendt's 1999 book, Wendt himself was given a chance to respond to his detractors in the 10th and final chapter. In his response, he spends the first 75% or so talking about this new idea that he was cooking up. An idea where he was thinking of an entirely new model for his constructivist theory to sit on top of. In his response, you can feel Wendt's enthusiasm so greatly that it eventually becomes unclear whether or not he's planning to get around to defending his book. He did eventually do that. In the last few paragraphs, he swatted away all 9 of his critics in short order. But at this point, it becomes clear that Wendt was focused on something else, something that looked much deeper into the future. So when the average person thinks about the social sciences, fields like psychology, sociology, political science, and so forth, he or she probably doesn't think about these fields in a physical sense. And what I mean when I say in a physical sense, very crudely, is how the laws of physics would interact or interfere with these various fields. So, for example, how gravity might affect Freud's theory of the subconscious. And when I cite that example, you probably think it sounds weird or just doesn't really make sense. And that is exactly the problem that our subject matter tries to solve today. So the social sciences as a whole are broadly considered what are called soft sciences. And these contrast with the hard sciences, things like physics, chemistry, and biology. What exactly someone means when they're calling a science hard or soft can vary, but overall the hard sciences generally explain very objective, natural topics. The fields are extremely well defined from a mechanical perspective and have very sophisticated mathematics behind them. And broadly, the hard sciences are more rigorous and are often going to use tightly controlled experiments and tests to advance their field. The soft sciences, meanwhile, are typically going to center on topics that are more subjective. They'll usually rely more on theory than experimentation. And instead of looking at things in the lab, Their practitioners typically have to go into the real world to get information. In 2015, Alexander Wendt released his next book called Quantum Mind and Social Science, which tried to address this exact disconnect. His main objective in the book is to try to at least jumpstart a deeper connection between the social sciences, which are his specialty, and physics in particular. And off the bat, Wendt doesn't claim that this disconnect is necessarily this horrible thing that delegitimizes the entire field. But he does make the point that it's quite difficult to ignore the significance of physics when considering the fact that, after all, the social phenomena that are studied in the social sciences take place in a world that is ultimately physical. And he makes the claim that, even though nobody really talks about it that much, the social sciences are generally understood to be rooted in classical physics. When we talk about classical physics, we're broadly referring to the earliest discoveries in the field. Ideas that fall under this category would include gravity, momentum, inertia, thermodynamics, maximum velocity, electrical flow. Folks like Galileo Galilei or Isaac Newton were famous classical physicists. And within classical physics, the contents, variables, and underlying math are generally understood in such a way that its phenomena can be very easily predicted with a near-perfect degree of accuracy. The game of pool is typically used as an example of classical physics manifesting itself in the real world. A good pool player will have the capacity to factor in all of the necessary variables: the position of the balls, the smoothness of the table's surface, etc., and use those to calculate the perfectly optimum shot to take. The best pool players, simply put, are those who are able to best abide by the laws of classical physics. As Wendt argues, a world that is classically physical is a lot like a game of pool. If you can plug all the variables into the corresponding formulas, you can predict just about anything. Taken to its logical conclusion, this leads to a pretty boring universe that is completely determined from the beginning to the end of time. In this type of realm, humans are simply objects which can be telegraphed perfectly, as if they were balls on a pool table. One claims that the social sciences have been, perhaps subconsciously, built on this type of classical model. The field of economics is a good example of what Wendt means. Much like physics, economics largely makes use of mathematics. This math is used to predict human behavior, and to do this, economists need to make the assumption that humans are rational, utility-seeking beings at all times. A particularly sharp manifestation of this assumption is within the field of game theory, where our decisions, our interactions, everything we do is boiled down to a series of games. In these games, we're trying to seek out maximum payoff at all times. Now, game theory is a legit field that can explain quite a lot, but no game theorist would ever claim that their methods would predict anything about human behavior with 100% accuracy. I think all of us would agree that when we're deciding to do something, yes, we want to make good decisions, we want to get the most out of it. But it's not always going to boil down to strategy or payoffs. There's certainly a gap there somewhere, and Wendt hops on this by suggesting that human life has a subjectivity or even an irrationality to it that really doesn't line up with this classical model of physics. Even in trying to predict seemingly simple things, like how someone will spend their paycheck, variability is inevitable. The eternal craziness of the stock market is perhaps a good manifestation of human subjectivity taken to an extreme. With all this said, Wendt's ultimate aim is to find a better physical underpinning for the social sciences and the reality of being human. He finds it in a much more recently developed school of physics, the confusing and strange world of quantum. If you listened to the first episode of this podcast, you may remember me saying I wanted to avoid explaining quantum physics, for the reason that it's just very confusing and difficult to wrap your head around. It looks like I will be breaking that promise today on episode 2, so please keep in mind I'm not a specialist in quantum mechanics. I have put in a fair amount of reading and research, and I'm confident that I can explain at least the very basics on this episode. But again, I'm not a quantum scientist in any way. I do bring this up because the interpretations of quantum mechanics have been used and abused over the years in ways that prop up some unscientific ideas. I won't say any more than that. If you're curious, you can Google quantum mysticism. But I just want to say that I will try to use the topic as responsibly and scientifically as possible on this episode. Quantum physics on the whole is the study of the very small, and in particular it's anything below the atomic level. Things like neutrons, electrons, quarks, so on and so forth. These all fall within the field of quantum mechanics. The field arose as a separate branch of physics because, plain and simply, the laws of classical physics don't explain much of what's going on at the subatomic level. The calculations and the math change significantly. The quantum world is indeed a different world from the classical one that we see. The character of the quantum has some interesting parallels with how humanity works as a whole, and in particular the subjective element that we addressed earlier. Before diving into Wendt's work, let's review a few of the basic principles of the quantum world. Things that we'll use throughout the rest of the podcast. One of the core ideas in quantum mechanics is something called the Heisenberg uncertainty principle. What this ultimately entails is that in the subatomic world, there is a finite limit to how accurately you can observe the exact speed and exact position of a particle at the same time. In trying to determine where a particle, such as an electron, is exactly, you'll lose the ability to measure how quickly it is moving. On the inverse, once you start to pin down how fast a particle is moving, its position in space will become murkier. This contrasts quite plainly with classical physics, where it's pretty easy to understand both. Because of the Heisenberg uncertainty principle, particles can also be viewed as a type of wave. In classical physics, particles and waves are separate things. But when studying particles at the quantum level, they exhibit qualities of both. So because we can't simultaneously observe the exact position and speed of a particle, they are more easily understood as something called a wave function. A wave function consists of all of the probabilities of where the particle might be at a certain point in time. So in this sense, in thinking of an electron, for example, in our mind's eye, we have to settle for probability instead of actuality. Now, if you think this is strange, things only get weirder once we bring in the observer effect. When particles aren't being observed or measured by something, they exist as a wave function, so that wave of probabilities. But once someone or something tries to take a measurement of where the particle is and how fast it's moving, the wave of probabilities collapses into a single, definitive point in space and time. So in essence, particles only move from probability to actuality once someone or something is there to see it. This may remind you of the old question: if a tree falls and no one is there to hear it, does it make a sound? The last and perhaps least intuitive concept that we'll talk about is called entanglement. If you listen to the first episode, you may remember I briefly touched on the capacity of two or more subatomic particles to become entangled with each other. This happens after some type of physical interaction. Upon becoming entangled, particles then begin to share the exact same physical properties. Once they're entangled, particles can henceforth be described using the exact same set of probabilities that make up the wave function. This connection holds over vast, seemingly unlimited distance and amounts of time. Entanglement ceases once the wave function is observed and collapses into the particle state. And perhaps the strangest thing about how this works is that an observation on only one entangled particle will cause all of its entangled friends to collapse simultaneously. This will happen even if they are light years apart. As I said, these concepts are strange and perhaps even a little unsettling. And while the interpretations and implications of these concepts are still argued over, this is the day-in, day-out reality that quantum scientists study. Even the most seasoned quantum specialist will tell you that it will always seem weird. Now, at this point, you're probably thinking, what does any of this have to do with social science? I invite you to Once Quantum Society. As I said earlier, Wendt poses the idea that the quirky, random character of quantum physics may underpin human nature better than its cold, classical counterpart. As Wendt describes it, a world dominated by classical physics is objective, perfectly logical, predictable, and predetermined. It's a strictly cause and effect world where distance is difficult to overcome. A world where the law of the land is totally unbendable. The people that fill this world are machine-like, unconscious collections of flesh and bone. Everything about their lives is destined and unchangeable. As Wendt puts it, they're zombies. Most of us wouldn't use this imagery to describe what humanity is actually like. Other than the most hardcore misanthropes, many of us sense a deeper, more subjective force that drives humanity. Wendt states that a quantum world is more in line with that image. The quantum world is an undetermined, probabilistic place with a thick interconnectedness. Wendt's image of people here is much more romantic. Conscious, free-willed beings who are subjects, not objects, and who have total control over their destinies. At this point, it may feel that Wendt is starting to open himself up to some sort of mysticism. He has admitted that he's aware of this, but the analogies that he draws to support his point are well-researched and quite stunning. Let's take a look at some of the big ones. One area that Wendt focuses on is human decision-making. In his classical world, people don't really make decisions at all, despite the illusion that they do. These automatons are simply responding to all the compounding physical causes that have led them throughout their entire lives. Even though we have brains and are seemingly conscious, free will doesn't really exist in Wendt's classical world. But plenty of us, in looking back on our lives, would place great emphasis on the choices that we've made. These choices helped build exactly who and what we are today. Now, the majority of our decisions are pretty minor, such as deciding between the curly leaf or flat leaf variation of parsley at the grocery store. but I would bet that all of us can think back on some huge decisions that unalterably changed our ultimate pathways. The quantum world, in Wendt's view, makes room for this choice-oriented version of humanity. To support this, Wendt cites a phenomenon from the world of cognitive psychology called the framing effect. This idea basically shows that, in contrast with economic theory, people are quite bad at making risk-based decisions. To illustrate, let's think about a package of ground beef that is composed of 85% meat and 15% fat. Just about every butcher markets this meat as 85% lean, even though it could also technically be marketed as 15% fat. So even though they're the same thing, why would it seem defeatist to use the latter label? These marketing techniques exist precisely because of the framing effect. Most of us are intuitively more attracted to the 85% lean label. Experiments have consistently shown results that confirm this disparity in a number of different cases. So in this sense, the classical, always rational model of humans doesn't really fit well with what we're seeing here. Something like game theory is going to do a pretty poor job of predicting these types of decisions. Wendt then cites several studies that show when a quantum mathematical model is applied to these disparities that are caused by the framing effect, it will do a far better job of predicting human decision-making than any economic framework would. So while quantum decision theorists wouldn't go this far, Wendt does begin to sketch the vision of humans as real-life quantum decision-makers. In his vision, every decision we make collapses one or more quantum wave functions in our mind. As he puts it, we are walking wave functions. With wave function collapse being a probabilistic phenomenon, our decisions are prone to randomness and anomaly. This, in Wendt's view, is a much better model for real life. Next up, Wendt makes the bold statement that our minds can become entangled just as subatomic particles can. This analogy factors in both the mechanics and consequences of entanglement. He states that humans are entangled with anyone that they are socialized with. This includes not only the people that we come into contact with directly, but anyone who we broadly share a social group with, people we have never met before. So I'm entangled with not only my family, my girlfriend, and my friends, but also all other males, other Americans, others in my age group, other podcasters, and so on and so forth. But most importantly, I'm also entangled with all other humans, just by virtue of being human. And the effects of being entangled with others is very real. To exemplify this, Wendt uses the death of Socrates as an example. After being forced to drink hemlock and subsequently dying, Socrates' wife, Xanthippe, despite being nowhere physically near the scene, instantly became a widow. This change in one of her social statuses occurred across a great distance and instantaneously. Another example that drives home the truly physical nature of this type of social entanglement is when a country goes to war. The exact moment a leader declares war, the physical safety of every one of that country's citizens, no matter where they are, particularly anybody in the armed forces, is going to change monumentally. Finally, in Wendt's boldest idea, he asks you to imagine that a few extraterrestrials are flying around in a UFO, having a look at Earth. Wendt asks the question, would these ETs be able to see our social structures? Meaning, could they physically see things like governments, or laws, or cultures, or class hierarchies, or any of the phenomena that the social sciences study. Other than some very crude manifestations of our social world, such as border fences or government buildings, it seems that no, it isn't likely that they would be able to see the social world that we humans have devised. And in a world of classical physics, this would mean that our social world doesn't really exist. But anyone who is alive knows that this isn't the case. The inner workings of our society have very real effects on our lives. And this is where Wendt proposes that society, our social world, is a hologram that physically exists in the minds of the people that make it up. Let me explain this a bit. Firstly, let's understand exactly what a hologram is. A hologram is a lot like a photograph, but is different in one important way. In a picture, every pixel contains information or data about only that specific pixel. So if you cut away half of a photograph, you lose half the data that the original photograph contained. Suddenly, the remaining half is incomplete and nowhere near as useful without the lost information. In a hologram, meanwhile, every pixel is encoded with all the information contained within the entire hologram. So if you cut away half of a hologram, you don't lose the original information. It just gets a little bit fuzzier. So let's imagine, say, the United States of America as a hologram. So even though our ET pals wouldn't be able to see America, or even infer its existence, what it means and what it is physically like to be an American, and the reality and consequences of those things, is installed in every single American's mind. Even if they are in America, overseas in space, or wherever, the entanglement and that hologram still exist. Now, the reality is that people pass away every day in the United States, be it from old age, car accidents, diseases, or something else. So even though every day many Americans move on to the next life, the idea of America doesn't go away. It just changes a little bit, with certain pixels leaving and new pixels coming in. And even though this hologram might not change much from day to day, it's still prone to huge, sudden shifts through the entanglement of its contents. On the morning of September 11th, 2001, we could argue that the hologram changed very radically. Now, this holographic society of once, as you may have guessed, doesn't fit too well with billiard ball physics. A society that lives inside of the minds of its inhabitants is going to lean pretty heavily on consciousness. Consciousness is something, as we saw in the first episode of this podcast, that's very difficult to explain in an objective, deterministic model. It fits a bit better with the quantum world. Another subject I touched on in the first episode is something called quantum consciousness theory. This idea proposes that consciousness is a result of physical processes that take place at the subatomic level. The reason that humans experience consciousness so richly is that the structures in our brains encase subatomic particles, protecting them from external observations. These external observations would collapse wave functions and ultimately interfere with these consciousness-inducing processes. In this theory, crudely put, quantum mechanics can explain consciousness in a way that classical mechanics cannot. Wendt acknowledges that the quantum consciousness theory is heavily disputed, and that this idea sits on some shaky ground. And while Wendt has come up with some very creative analogies here, I think it's important to state that they could just end up being no more than analogies. While quantum physics is well established and among the most rigorous scientific fields, it's still pretty young. And in comparison to classical physics, it's extremely difficult and expensive to study in the lab. But Wendt himself is upfront with the idea that he just wants to sketch a framework which would fit more cleanly with the optimistic view that he and many others want to take about humanity. But the truth is, even if it's wrong, Wendt's earliest point is that the physical nature of the social world is something that is completely unexplained. And it really does seem that quantum theory, as it develops, has a better shot than classical physics to fill the gaps. But perhaps more importantly, the Wendtian world that we've discussed, whether it's perfectly accurate or not, could lead to some staggering insights into our current reality. An important idea that Wendt uses to tie together quantum mind and social science is that language is a physical object that functions similar to light. Language, like light, can travel vast distances at speeds that the human mind can't really comprehend. They both illuminate, highlight, and ultimately create our visual reality. Without language, we wouldn't be able to see, hear, or in any way perceive anything about the social world. And this physicality does make sense. Think of the attempts to evolve language into more politically correct forms. Changing the words or phrases that people use takes years and years. Getting it done almost equates to the effort it takes to dig a stubborn tree root out of the ground. The importance of language has been acknowledged for some time in philosophy. Jean-Jacques Rousseau hypothesized that societal inequality didn't emerge until humans became capable of speaking with one another. Without language, he argues, there was no way to make comparisons between two people. Without language, there's no true mechanism for humans and society to build today's hierarchical structures. Another philosopher, Michel Foucault, posits that language is one of the key pieces of technology that today's governments use to exercise power and control. And plenty of prominent metaphysicians have even argued that language serves as the entire basis of our existence. Martin Heidegger, in particular, warns that the misuse of language can even destroy our current reality. So in this sense, Wendt's treatment of language isn't radical or new by any means. But what he has done is posed a way to solidify language's importance in a way that fits with the model of the quote-unquote harder sciences. When applying some of Wendt's concepts to broader life, particularly the idea of entangled minds, a few things become clear. First, our relationship with and importance to society now has a physical basis. Society in its current form could not physically exist without you and me in it. Its current state is as much a result of your life and your decisions as it is anyone else's. More importantly, not only our actions, but our words have everlasting effects on the construction of society, effects that ripple throughout time. This idea is more important than ever in 2019, as the power of the internet and social media continue to grow seemingly exponentially. But the reality is that within Wendt's model, we are still only just one pixel of several billions in this holographic world. Our fractional share continues to get smaller as the global population grows. Alone, our impact can only be so great. However, Wendt's concept of entangled minds does make great social change possible through collaboration and cooperation with others. As the potential for entanglement increases through technological advances, the potential to change the interconnectedness of humanity's myriad social groups also strengthens. And while we can chop up the different types of combinations of entangled groups in nearly infinite ways, one dichotomy that cuts right into the mechanics of entangled minds is those we share a native language with. As a native English speaker, I am highly entangled with other English-speaking minds, especially today. Just about all of us are exposed to the same news streams, same trending hashtags, the same entertainment. Because of our connected wave functions, we're able to affect each other through these shared meanings. In contrast, my connection to people that speak only French, or only Cantonese, or any other language that I don't understand is much, much weaker. I am arguably cut off completely from their daily worlds. The impact of their words on me and mine on them seems pretty limited. In Wendt's world, the words of this podcast create an entanglement between me and all the minds that listen to and understand it. But a person who speaks only Cantonese who listens to my words feasibly won't be able to join in on that entanglement. Unless, of course, the words are translated by some sort of already entangled intermediary. Wendt's model doesn't imply any sort of direction that we should all take. But what all this says to me is that things would at least be a lot more interesting if we all spoke the same language. For the entire planet to be entangled under one language that we all understand would mean that our social reality would be completely representative of the whole. Our capabilities to impact other people wouldn't be limited to those in certain countries or certain continents. Our collective strength would increase greatly. Of course, fulfilling this vision is easier said than done. English is considered today's default lingua franca of Earth, but estimates fall between only 20 and 25% of people actually understanding it. An even smaller portion of those speak it as their first language. There's clearly quite a long way to go. In my personal opinion, globalization will inevitably push us toward increased mutuality and perhaps singularity within spoken language. And I think this would be a good thing. Being entangled with others seems to increase our capacity for caring for and empathizing with them. It increases our capacity toward ultimately understanding them, and likewise ourselves. The idea of quote-unquote the other begins to fade. My interests start to meld with the interests of all, and vice versa. It's a world of beings that constantly reflect upon each other. A multifaceted feedback loop. The endless images of two mirrors reflecting upon each other. For the entirety of our social science to physically and metaphysically rest on quantum mechanics, the subject will have to reach a point where the layman can easily talk about it. We need to get to a point where its contents are less challenging to our intuition. But until then, even without understanding the exact mechanics, this theory serves as a reminder of the importance of the mind in understanding our world. Much of what we see today, things like buildings, airplanes, homes, social clubs, before these things existed in the world, they started in the mind. And one of the tougher truths to come to terms with is the fact that none of us that we know about asked to be born into this world. Perhaps naturally, very few, if any of us, are 100% satisfied with how society is run. And in that vein, what Wendt also reminds us is that by virtue of being part of a society, we have the power to change the things that we aren't happy with. As Wendt puts it, Humans are naturally built to cooperate with each other by default. Conflict is what most people shy away from, not collaboration. And if he's right, the entire model may allow us to understand the physical rules of our morality. All right, that's it for episode 2, everybody. I want to thank you again for listening to this podcast. It really means a lot to me. Again, I really enjoy putting these together and hope you all get a lot out of them. We've got several more lined up. I'm going to start aiming to put these out once a month. There's a lot of work that goes into them, a lot of reading, so it's not something I don't think I can do every week or every 2 weeks. So we're looking to put these out monthly. Got a few exciting topics coming up, but please hit me up if you have anything you think would be interesting for me to talk about in the future. There's only so many of these ideas sitting out there, and they are kind of hard to dig up in some cases. So hit me up on Instagram or Twitter, at Grand Theories on Instagram, and Twitter is at Grand_theories. Again, thank you guys for listening. Looking forward to many more episodes. Take care.